really around us. The name of the chapter is Magnetism. This is the title course, and once you are preparing for the final round, it's always helpful to see the syllabus. Practical investigation, like the practical skill, should be considered as a special unit and should be, if the lab is there, then it's very good. If you haven't done it in lab, then you just type in the same 2 lines in the Google YouTube and see what Google with the title IGCSE Edexcel. So in that way, you can improve the practical investigate line. The benefit obviously is that if you have done it in lab, then obviously the main skill is there. Otherwise, you can cover it from the YouTube. I'm starting my title introduction. I'm putting the first concept. Magnet is a natural resource, something like oil, something like steel, gold, silver. They're coming from our natural planet. So magnet is originally a natural resource, and it was found by chance, and it was specially capable of attracting iron, steel, and some other substances. Our course do not consider any other substance except iron and steel, so we focus on only iron and steel. This is the horseshoe electromagnet, the famous horseshoe U-shaped magnet, and this is the famous bar magnet. It is originally a steel rod. It is originally a steel rod which is painted red and blue or red and black to show the poles. It is an artificial magnet. Now, these are the common magnets you find in your school laboratory. Now, I'm putting the first title, Poles of a Magnet. So after giving the chapter name, give the heading, Poles of a Magnet.
Done.
Right. Poles of a magnet. What is the theory? That when a bar magnet is suspended freely, it will swing itself and it will stop in a position where one of its pole is pointing towards the north of the earth and one of its pole is pointing towards the south of the earth. This was the first time humans identified that our planet also has a magnetic field, a proper magnetic field. And when a bar magnet is suspended freely, it will move. It will move here and there, like this is a suspended bar magnet. When it moves freely, it will stop in a position where one of its end is pointing towards the north of the earth and the other end is pointing towards the south of the earth. Interestingly, they made a very interesting step. The corner which is pointing towards the north of the earth, they called it north. Otherwise, by rule, it should be south because north and south attract, north obviously repel. But they put it there. North is facing north. This was a convention. This is how the polarity of a magnet started. This is an investigation. You suspend the bar magnet freely like a thread, or you put the bar magnet on a piece of wood and you allow the wood to float on water so that it can move freely in any direction. It will swing itself and it will show the direction of the earth magnetic field. Now, the laws of magnetism. The laws of magnetism says there are two proper laws. First, like poles repel each other, and second, unlike poles, attract each other. These are very famous, well known from our science classes, earlier science classes. We know magnets are in our homes also. So we know that magnets have a capacity of attracting iron. They also have a capacity to repel other magnets. They have a capacity to attract other magnets. Now you have to see this screen. The two north and south, they attract each other. North and south attract, but same poles repel each other. Now there are some important applications of magnetism. So you have to give the heading applications of magnetism.
Done.
Now there are some important application: navigation tool, a source of attraction, data storage, and electromagnets. This is a list covering all important applications of magnets. So you have to copy this list.
Done.
Now, magnetic compass. This was the first human known navigation tool. Before that, humans used to travel by stars. Stars were naturally aligned in the sky, and people used to travel on the stars using the stars' position. They used to travel in the desert, in the waters. But when this came up, it was a revolution. And this compass needle is able to show north and south. Then they thought about searching for iron because magnets are specially attractive towards iron and steel. So they use, now still they use it. In the scrap yard they separate iron. This is a door catcher, a general example in our homes. Now this example is a conventional hard drive. Hard drives are magnetic systems which store data. And again, this is the conventional. Now, the new hard drives are not using this pattern, but this hard drive, which I have shown, has a magnetic core. Data is stored in form of signals. This is electric bell. Nowadays, electric bells are not that type. Majority homes have those polyphonic tones, which have multiple tones, and you can change the bell tone. But this is the conventional old style bell which produces a typical hammer sound. And it is one sound. It was a mechanical electrical bell, not common now, but this was the first bell humans got in electromagnets. Now we have the title magnetic induction. So you have to give the heading magnetic induction.
Done.
Magnetic induction. What is magnetic induction? The theory says that iron is a very close friend of magnet. Magnet is a natural resource. Iron is also a natural substance, but iron is a pure element. Magnet is not an element, magnet is actually a type of mixture. So iron was discovered to be a material which is attracted towards a magnet, So when a magnetic substance like iron is brought near to a magnet, it also behaves like a magnet. Look at this. North-south is a proper magnet. This is a proper magnet, but paper clip is not a magnet, but it is made up of iron or steel. The paper clips attract and get stick to the iron. This is called induction. Look at this iron nails. They stick to the original magnet back to back, back to back. This is called magnetic induction. Magnetic induction is basically a type of penetration of magnetic field. They won't become magnet, but they attract each other like magnet. So when you put a magnet near iron rod acquire a magnetism. This is called induction of magnetism. The paper clips, iron nails, look at this iron balls, they are attracted. So after giving the heading, you have to copy this.
Done.
Okay. Now this is called magnetic induction. Now magnet, non-magnetic and magnetic materials. Now we have a very good understanding to be made here. Magnet is a natural stone. There are two magnetic substances which get interactive with a magnet, iron and a steel. From chemistry, steel is not something new. Steel is an alloy of iron. So actually, only one substance interact with magnet, that is iron. Iron, iron and steel are actually the same thing. Steel is an alloy of iron. Apart from iron and steel, all other substances are non-magnetic. They do not interact with magnets. So you have to copy this.
Done.
Now, classification of magnets. There are two type of magnets. One are called permanent magnets, which we found from the earth. They are just like a natural resource. And definitely this is a definite limited resource. Then electromagnet. Electromagnet are those which work on current. They are coming from current. They are actually originating from the electricity. So now we move forward. The important uses of electromagnet, like nowadays, the trains, we use the high-speed bullet trains, loudspeaker, relays, electric bell, industrial lifting magnets. these trains, which is travel with a very high speed, are magnetic trains. These are high power lifting magnets. Now, now we have to put our next concept. The next concept says the difference of iron and steel. Now you have to give the heading iron and steel. You have to give a heading iron and steel, and write under it that give the heading iron and steel. I'm getting the screen back. Give the heading iron and steel, and write under it that is a iron is easy to magnetize. Iron is easy to magnetize and easy to demagnetize. Iron is easy to magnetize and easy to demagnetize. Now, this is the concept we are building now. We are starting iron is easy to magnetize and easy to demagnetize. So iron is suitable as a temporary magnet when you need magnetism for a glimpse, you want to demagnetize also. So iron is suitable when a temporary magnetism is needed, and just like computer RAM, etc. So the random access memory or anything in which magnetism, like a loudspeaker, like a doorbell, where magnetism is temporarily needed. So when you switch off, the magnetism has to go off. So you have to copy this also.
Done.
So this is the behavior of iron. Now comes in steel. Steel is an alloy of iron. Steel is an alloy of iron. Steel is an alloy of iron, and steel is hard to magnetize and hard to demagnetize. So when you need a permanent magnet, like suppose inside our motors, generators, there are permanent magnets like the door catchers, like the steel needle inside a magnetic compass. We need permanent magnet. So this is where steel is used. You have to copy the last two lines.
Done.
Now give a new heading, magnetic field. Our course, Edexcel course, focuses on this topic a lot, and they want students to go in the lab at least twice here and do 2 or 3 important investigation involving the magnetic compass and iron filings. So have you gone in this title in the lab?
No, we didn't start this chapter yet.
Acha, but you told me that apart from acha, oh, there's a confusion now because actually by January, I think January in our discussion last time, except astrophysics, I think they are going to do everything. This was a discussion, or I'm remembering it in wrong. Something. Let me check the record.
No, they just skipped this part. We did. What was that topic?
Electromagnetism.
No, before it, we did that unit.
Ele-
We astrophysics, and we did that, and then after that, we skipped electromagnetism, and then we moved on to radioactivity. So we're doing that now. But I think they're gonna finish that and then move to this.
Because logically, January is the second last month. Normally in February, school wind up everything. Maximum, they will leave one chapter. I don't think so. They leave there one chapter also. Majority school wind up everything in January. But maybe you can still ask your teacher if they, or you can check your notebook and because how they have done electromagnetism, because electromagnetism comes after magnetism. So they must have done it maybe quickly because normally magnetism doesn't stand alone. So I think so that let's see, you can double check it because I feel that if they have done electromagnetism, they must have done magnetism because they come side by side. Actually, have they done a static charge?
We did first thing this year we did was density and pressure,
Mhm.
solid liquid gases, and then we did internal energy, and then
Okay,
we
do
started.
one thing. I think that will be, I got your idea. I think do one thing when you go to school next time, just ask your teacher that what topic is not coming in January exam. That's easy because everything actually comes in. So, actually, any test or anything in November or December?
For sciences, no.
Acha. But if they announce any test, you have to tell me so we can skip to that because we have to see some teachers take some teachers take random test. So it is possible that the magnetic field is my title. Okay. This topic is important. You have to mark it important. They want people to study a lot about it. They want people to make a research in the lab, at least 2 activities, investigations, and normally the iron filing experiment is less common because of some health issues related to iron filings, but compass experiment is very common. So let us no problem proceed with that. What is a magnetic field? Magnetic field is a region in which a magnetic pole experiences a force. A magnetic field is a region in which a magnetic pole experiences a force. This is like a concept that Wi-Fi has a range, Bluetooth has a range. Similarly, mobile company signals have a range. This range is actually called as field. Field is a range in which signals are detectable. So copy down the definition.
Done.
This is the definition of magnetic field. Magnetic field is a force field. We use imaginary lines inside the field. We use imaginary lines like these lines. Now you look at this diagram. Do you remember this diagram drawing in your class anytime in this year or previous year?
No.
Okay, now this is strange.
We just did electromagnetic like waves. We just did that.
And what about motor effect, loudspeaker?
No.
And what about that chapter we were doing before that, V is equal to IR?
Yeah, that we did.
Hmm. So I think some chapters are different. So we will align ourselves, inshallah, once you go and ask the teacher. And once you get free, then you can sit and you see what topics you have done. And then we can align our work. But in my understanding, if there is no test, we can continue our own. And normally in January, when the schools which take the mock in January, normally by that they finish majority chapters except one or two chapters. Your school in January will take a mock. Will it be they call it final mock, or they will take another mock in March?
It will be final probably.
No, how it's possible? Because normally December, January is mock one, and then February, March is mock two.
We did mock 1 in September.
Acha, 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 acha. Acha, this is it a British school?
Yeah.
Acha, acha. Acha, it's a British school. Acha, what about then expected grades? Do they follow the expected grade for IG, or they do not follow that?
Yeah, they do.
Hmm. Acha, now I understand it. Oh, then I'm clear. Then even then by rule, by the end of January, they actually clear every topic. And even astrophysics they can complete. By rule, if it's a British school and they follow the British calendar, then they will wind up everything. Let's see. Let's see now. Acha, magnetic field is a force field. So we draw imaginary lines around the magnet. This is called a bar magnet, and this is a field imagination. These are the two magnets facing each other, and these are called field lines. We draw field lines. We draw field lines. Left side is a U-shaped magnet, and the right side is a bar magnet. So these lines are showing the field pattern. Field pattern is, they like it a lot. They want people to draw the field lines. They want people to go in the lab and draw the field lines there. So now what is the convention? Field lines are always north to south outside the magnet, and they are not allowed to touch each other. They are always separated from each other. So now we have this pattern around the bar magnet. We have this pattern around the bar magnet. So you need a pencil ruler and you need good drawing. Good drawing means the lines should not touch each other. So now you have to copy this diagram neatly. I'm just coming in a minute. I have to say namaz. Copy this diagram neatly. Have you drawn it?
Yeah.
Okay. So this is basically a drawing. This is basically a drawing showing field pattern around a bar magnet. The lines do not intersect each other. The direction of the magnetic field is always the direction of the force. So it is actually, when you draw a field pattern, you draw lines not to south outside the magnet. This is the horseshoe magnet. This one, this is showing the field lines around the bar magnet. Now, the relative strength. Now, this is our next concept. How we show the strength of a magnetic field. How we show the strength of a magnetic field. We show the strength by the field lines. Look, on the left side, it's a weak magnetic field. On the right side, it's a strong magnet because the lines are closer. Closer means stronger magnetic field. So when you draw a magnet, field lines are shown north to south outside the magnet and south to north inside the magnet. This is a convention to follow. Now, this is a field pattern showing attraction between north and south. Our course wants people to go in the lab for this also. There are two important investigations. They want people to go in the lab using a compass or iron filing. They should be able to draw these lines. Right now, we are plotting it directly. So you have to copy this.
Done.
So this shows the magnetic field between unlike poles. Now you have to. I have shared with you two PDFs. One for paper one and one for paper two. You have to open the PDF for paper two. So this is page number 59 from the book 2. Have you opened book 2?
Yeah.
Uh, PDF page number 59. A student uses a watt meter to measure the power of the electrically operated appliances. What is meant by the term power?
The rate of energy transfer.
Very good. Rate of energy transfer. Toaster, kettle, laptop, electric drill, television, hair dryer. Read the question. He had described in the start of the question that this is a apparatus which is helping him to determine the power of electrically operated machines. So now we have defined the power. He's asking us to make a table. This is a 2-mark question. He says draw a result table for the student results. So let's make a simple table. So please draw with me. So we put number here and we put appliance appliance here and we put power in watt. And then we put 1, 2, 3. Then we just copy the toaster and everything. Toaster 1068, and then kettle 2025. In this way, you have to make the table. Laptop 47 watt. And electric drill 713 watt. And then television 59. Then television is 59 watt. Hair dryer 1511. Hair dryer 1511. Okay. So please share with me. Oh, sorry. Please let me know once you complete this table with me. You know,
Done.
measures the power output for a different appliance. Diagram 2 shows their raw data. Now, a student find an anomalous result. For a different appliance 199, 202, 201, 200, 201. Which number is looking a bit away from the average?
213.
Hmm. Now you have to find the average. You have to ignore this 230 anomalous result. So now find the average. Plus 201 plus 200 plus 20. I have 1, 2, 3, 4, 5. Okay, so can you find the average for me?
It was 200.6, but then I rounded it to 201.
It was a 7-mark question and we completed it. This was a nice, easy question. Now I'm taking a question from 2022. You have to double check with your teacher that we are doing this code. Even I'm sure it's the same code, but I want to double check about this double award or triple award. What paper
Yeah,
you
we are doing this code.
Hmm? Sorry. So I couldn't actually get what did you say? It was
I said that, yeah, we are doing this one.
but is it double award or triple award?
Triple.
This is the thing to discuss now. I have posted it, so you can double check it. Now look at this question. This is question number 7, June 2022. These type of questions are there in the double award syllabus. And you said you people are appearing for triple award, right?
Yeah.
Okay. So what is meant by the term electric current?
Current is the flow of charge.
What was the complete definition? Rate of,
Flow of charge.
yes. This is the definition for rate of flow of charge carrier. This is the definition for electric current. So we stop here, and we will inshallah continue in our next class. Okay. Thank you.
Allah Hafiz.